Tidal power. Tidal power is the form of hydropower generation, which converts the energy from the natural rise and fall of the tides of seawater into electricity. As we know, the sea tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Note: tides are caused twice a day due to combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Coastlines often experience 2 high tides and 2 low tides on a daily basis. In order to generate meaningful power output from tidal power, the difference between low tide and high tide must be at least 5 meters. Tidal power can be generated from various technologies, and these are: tidal barrages, tidal fences, tidal turbines. Tidal barrages are considered to be most efficient way of producing the tidal power. In this case, a reservoir is made on a narrow opening of the sea, and when there is a high tide, the gates of this reservoir are opened. Turbine has been fitted at the bottom of barrage. When gates are opened, water rushes from the sea into the reservoir, and hence turbine rotates. When turbine rotates, we get the electricity from the generator, which is coupled with turbine. Note: during high tide, water flows from the sea to the reservoir. When water level is equal at both the sides, gates of reservoir is closed. When there is a low tide in the sea, we have a high water head in the reservoir and low water head in the sea level. At this situation, we again open the gates of reservoir, and this time water flows from reservoir into the sea. This causes rotation of turbine, and electricity is generated. Note: in tidal barrage arrangement, electricity is generated 2 times per tidal phenomenon, since high and low tides occur twice a day, meaning we can generate electricity 4 times in a day. Tidal fences. Tidal fences are turbine that operates like giant turnstile, which rotates continuously. Electricity is generated when the mechanical energy of the tidal current rotates the turbine connected to a generator, which in turns produces electricity. Tidal turbines. Tidal turbines are similar to wind turbines, which are commissioned under water. Electricity is generated when the mechanical energy of the tidal current rotates the turbine connected to a generator, which in turns produces electricity. Note: sea current generates relatively more energy than air currents, because sea water is 832 times denser than air, therefore applies greater force on the turbine. Advantages of tidal power: no direct greenhouse gas emissions, low environmental impact. Tidal patterns are well understood, hence tidal energy is very predicted energy source. Disadvantages of tidal power: adoption of tidal power is low due to very specific site requirements are necessary to produce electricity. It can only be commissioned along the coastlines. Tidal cycles do not always match the daily consumption patterns of electricity, therefore, they do not provide sufficient capacity to satisfy demand.